Welcome back everybody, Gary Simmons here for the Game Institute with another tutorial in the Dead Earth game development series. In this lesson we are going to create a more advanced interactive object which will have several moving parts, quite literally. We're going to create the elevator sequence which allows us to complete the level in Creeper. We're going to create an elevator platform and place it in this square here at the bottom of the shaft. And we'll also need to create an animation so that when it's activated, the elevator will move slowly up the shaft, and at the top of the shaft, we're going to have a trigger that detects when our player character has entered it, and that's when our game knows that we have completed the level. To activate the elevator, we will have a keypad on the wall. It's the keypad itself which will be the interactive object, but unlike the simple interactive objects that we've created so far, this one will behave differently based on several conditions. You see, in Creeper we have to accomplish 3 goals in order to escape the level in the elevator. Firstly, the elevator won't work because there is no power, so we have to find the generator and turn the power on. But that's not enough, because when the power is turned on and electricity is restored, the level has been put into lockdown mode to stop any zombies escaping. But turning the generator on has activated a computer system. We need to find that computer system and use it to deactivate lockdown mode. But even then, with lockdown mode deactivated, if we were to return to the keypad, it would still say we can't leave because we don't have the access code. We're going to have several dead bodies placed throughout the level that our zombies can feed on, and we're going to place the access code on one of those dead bodies. And furthermore, each time we press play, we're going to randomize which one of those bodies the keycard can be found in. The interactive object that we're going to create in this lesson for the keypad then has to be aware of 3 different states in our game: whether the power has been restored, whether lockdown has been deactivated, and whether the player has the access code. And each time, if we were to return to the keypad, our interactive keypad object would tell us something different. So when we start off and we walk up to the keypad, it will say something like, keypad, you need to activate power, or something like that. So you activate the power. If you were to come back to the keypad then, it would give you a different message. The power is now activated, but it would tell you that you can't leave because lockdown mode has been activated. And if you were to then deactivate lockdown mode and go back to the keypad, it would tell you something different. It would say access code required. Finally, when you have all of those goals accomplished, if you return to the keypad, it will allow you to activate it. So it stands to reason that as well as having to generate the animation for the elevator and the keypad interactive object, we're also going to need to implement some system in our game for storing and retrieving game states. That's going to be the job of the Game State Dictionary, and we'll create an application manager class that contains that Game State Dictionary. The great thing about the Game State Dictionary is it will just be a dictionary of string keys and string values. The key will be the name of the state, such as power restored or lockdown initiated, and the value will be another string that will just be true or false or whatever value we think makes sense for that particular state. Using a simple dictionary in this way allows us tremendous power, and in fact in the early days of gaming, a simple system like this would be used to devise the entire quest system of a text adventure or a simple RPG. Of course, in today's RPG systems, we really need to use something a little more advanced and easy to manage, something that's more modular, something that subdivides those states into modules called quests, and then perhaps even further subdivides them into quest steps. But even so, you could create some really complex stuff with just a single dictionary of states. So when we activate the generator to restore power to the level, that interactive item will contact the Game State Dictionary, and it will make sure that power on equals true. And when we deactivate lockdown mode or find the keycard, those 2 triggers will also set their respective states in the dictionary. This means that when we try to activate our keypad trigger on the elevator, it can check the Game State Dictionary and can return different feedback to us based on how those states are set. So I think the first thing we'll do in this lesson is we will create our application database manager, which will contain the Game State Dictionary, and implement the functions that will allow any script to set states and also query states. And we'll also configure the inspector of the application manager so that we can also type in some initial states that we would like to have set when the game begins. And finally, before we get started, the application manager is eventually going to be used for many other things. It's going to contain functions that will allow us to load in the game level, load in the closing credits scene, or load in the title screen, and basically just control the overall flow of the game. The application manager will be another one of those singleton objects like our game scene manager, but like our audio manager, it will also be a don't destroy on load object. This means as we move from one level to the next, the states will be maintained between levels. Now that's not really something that we want in Creeper because it only has one level, and when we go back to the title screen, we're going to want to reset all of the states again. But in a game like Dead Earth that has multiple levels, any states that are set on one level really need to carry over into the next level. Eventually, once we've completed the Creeper game and created a title screen scene and perhaps a closing credit scene, we're also going to create a bootstrapper scene. That simple scene will be the first scene to be executed by Unity when our game is run, and it will only ever be run once. Its main job will be to load the title screen. However, because that scene is only ever loaded once, it is in that scene that we will eventually instantiate our audio manager and our application manager, and we will remove the instances we currently have in the main game scene. That's important because they're singleton objects, and if we didn't remove them from the game scene, then every time the player chose to play the level again, the scene would be loaded again, and because then don't destroy on load objects, another copy of the audio manager and the application manager would be created. Okay, so with all of that said, let's now create our application manager script. So I'm going to create this in my root scripts folder along with my game scene manager. I will keep all of the managers in the root. I'm going to create a new C# script, and I'm going to call this application manager, like so. Then I'm going to open it up in MonoDevelop. I'm going to remove the boilerplate code for now. I think I do want a start function, but I will add that as and when I need it, as I think that makes the tutorial easier to follow. So because we want our application manager to be a singleton object, the first thing we will do is create a private static member of type application manager called instance with an underscore, which we'll set to null by default. And then of course we have to create a public static property called instance, which any other script can call when it needs to get access to this variable. And of course the property also needs to detect whether this is null, in which case it's the first time the property's been invoked, and then it will first do a search through the scene looking for the application manager component. So we'll create a public static property called instance that returns an application manager reference, and it only needs a getter. And first of all, we'll check if the instance is null. If the instance is null, it's the first invocation of this property, and we need to search the entire scene to find a component of type application manager, and of course there should only be one. So we will say instance equals, and then we will use Unity's find object of type function, and of course the function takes a type, so inside the parentheses we will say type of application manager, and then of course we will return that instance to the caller. And we also said that we wanted this object to be a don't destroy on load object, so we'll create an awake function, and inside the awake function we will call Unity's don't destroy on load, passing in this game object. So next up, we wish to declare the dictionary that's going to hold our game states. I'm going to create a private dictionary member that takes strings as a key and also a string as the value, and I'm going to call this game state dictionary with an underscore. And then we will create two functions. The first will allow us to register states with the dictionary, and the second will allow us to retrieve states from the dictionary. So at the bottom of the class, I'm going to create a public function that returns a string called getGameState. And of course, as its only parameter, it takes the string that we are looking for. So this is the state that we are inquiring about, and it will return the value that has been registered with that state. So we'll create a local variable called string that will contain the result, and we'll set that to null initially, and then we'll use the dictionary's try_get_value function to see if the key passed exists in the dictionary, and of course if it does, then this resulting string will contain the value of the state, and then we simply return that to the caller. Let's now create the setGameState function, which any script can call, such as our triggers, when they wish to set or change the value of a state. And first we'll check that the key in the value that's been passed in isn't null. And if it is, we'll just return false and not set the state. I'm not going to allow null values in our dictionary. That's just a personal choice. Then of course, we will simply assign the value to our dictionary using the passed key, and we'll return true in this case to say that the state was set without any problems. So our game state dictionary is now complete, and we have functions to get and set states in that dictionary. But I also said that I wanted a way for us to be able to set some initial states via the inspector. if we wanted to. Now, we can't just serialize the dictionary because dictionaries aren't serializable. They don't show up in the inspector in Unity. So what we'll do instead is we will serialize a list to the inspector, and the elements in that list will be string pairs. And then in the awake function, when the game first starts, we'll be able to iterate through the list and copy the keys and values from that list into the dictionary. So we'll start by creating a helper class called GameState, and we're going to make this system.serializable so that we can set it via the inspector. And it's going to have two members. The first one is a string called key, which is set to null initially, and the second is a string called value, which will also be set to null initially. And then in our application manager, we will serialize a list of game states that I've called starting game states. Okay, so this is the thing that will show up in the inspector. And because each element in this list is a game state, these are the elements that we will see showing up in the inspector, and we'll be able to set a key and value pair for each state that we wish to have initially set. So now we'll scroll down and we'll set up a loop to iterate through all of the starting states, and then we can copy them over and set them in our dictionary. So we'll get the game state that we're currently processing in this iteration of the loop, and then we'll set it in the dictionary by saying GameState dictionary, and we'll use the key of our game state as the dictionary key and the value of the game state as the dictionary value. And that is our game state system now complete. So we'll go back to the editor now and check we haven't got any errors. And then from the game object menu, we'll create a new empty game object, and I'm going to reset its transform so it's at 0, 0, 0 in the world. Not necessary, just something I like to do for manager objects. And I'm going to rename this game object, and I'm going to call it Application Manager. And then with the Application Manager selected, I'm going to add the Application Manager script that we just created to it. So there you can see we have an Application Manager component on our Application Manager game object, and it has this drop down of starting states. And if I set it to say 2, you can see that this gives me 2 elements where I can set keys and values, and we've already seen that in the awake function of this component, the keys and values are going to be stored in the dictionary where they can be more efficiently fetched and set at runtime. So for now we won't set any states, we'll just set it to 0. So next up we need to create the elevator floor. This is going to be a simple cube that I'm going to add one of the materials that's already being used in the scene to it. So I'm going to go to the game object menu, the 3D object submenu, and choose to create a cube. There's the cube. So what I'm going to do is I've written down the settings for the position, rotation and scale. So what I'm going to do is I'm just going to paste them in, and then you can pause the video and copy down my settings. Saves me messing around for 5 minutes trying to get this thing to fit exactly. And there is our elevator cube resized so it fits within the shaft. Like I said, pause the video and make a note of those, or you can just line it up yourself using the translate and scale tools. And the next thing we need to do is find a material to put on this so it doesn't look so ghastly. And there was a material in this project somewhere called tile_floor concrete slab. So what we'll do is via the mesh renderer, we will open up the material picker window and we'll type in tile, floor, and there it is. It's this one here, tile floor concrete slab. So let's apply that one. Okay, it doesn't look great, but it'll probably look a little bit better when we've got this scene properly lit. See, that doesn't look too bad. So now what we want to do is make an animation for this floor piece so that it moves up the shaft slowly when it's activated. So if we need to create an animation, we probably need to create a folder to store it in. So inside my animations folder, I'm going to create a new subfolder, and I'm going to call this interactive. And in this folder, we'll store all of our interactive animations. So with our interactive folder set up and ready to receive the animation we're going to create, I'm going to rename our cube game object and call it elevator, like so, and then I'm going to go to the window menu and open up the animation window, okay, not the animator window, the animation window. And it knows that I have a game object selected and that that's the object that I wish to create an animation for. So in order to create that animation, I press the create button, and then it's going to ask me where I wish to save that animation to, and it's automatically selected in this instance that interactive folder that I just created. But of course, if it didn't do that, you can go there just as if you're browsing the file system normally. So like I said, I'm going to store it in the interactive folder, and I'm going to call this animation elevator and hit save. And the animation window has now changed and it's waiting for me to put keyframes in for this object. So we will zoom out a little bit. We want this to be about 15 seconds long, and at the moment it's only showing a second on the timeline. Okay, so I'm going to zoom out so that I get about 15 seconds worth of time on the timeline, and I'm going to press the record button now, and Unity is now waiting for me to move that object, which will stamp a keyframe into the timeline. So the elevator floor is already where we want it to be for the first keyframe. So what I'll do just temporarily is tweak one of the settings in the inspector. So I'll go from -21.96 to -21.97 and then back to 6, and you'll see it's now recorded that keyframe. And then what I'll do is drag the timeline along to about the 15-second mark, about there, and then I'm going to move, just using the standard transform key, the game object up the shaft to where I think I want it to be at the end of the animation. I think on this last run here, yeah, about 9.42. Okay, and then I'm going to unselect the record button, and that is our animation complete. And in fact, we can actually see this play out by previewing it. So let me take the timeline back to the beginning and then press play from within the animation window. Hey, there is our elevator moving up towards liberation for our player. Cool stuff. Let's just check it goes to where it's supposed to go. Cool. Okay, so I'll unselect the play mode and I'll now close down the animation window. Our animation is complete. However, notice that if you look at our game object now, Unity has automatically added an animator component to it, and it's also been assigned a controller called Elevator. This animation controller was also automatically created by Unity when we created that animation. So let's just select the Elevator animator controller, and you can see that by default it's put it in the same folder as the animation, but I have a separate folder for all of my controllers, so I'm going to drag and drop my Elevator controller into the Animator Controllers folder. Now, the Elevator controller isn't how we want it at the moment. The default state is our animation, so this elevator will start playing as soon as we press play. At least I believe that's the case. Let's press play, make sure I haven't maximized the game view. There you go, the elevator is just moving by itself, and of course we don't want that to happen. We want some trigger to cause the elevator to move. In other words, we're going to want our keypad trigger to tell the animator when it's time to play the animation. So in order to do that, we will create a new empty state, and we will make that the default state for the layer, okay? And I'll just rename that by selecting it and via the inspector typing in empty. There you go. So of course if I were to press play now, the elevator wouldn't move at all. Perfect. That's exactly what we want. Going back to the animator window, what we need to do now is create a parameter. So I'm going to call up the parameters tab, click the plus sign, and we're going to create a trigger, and I'm going to call this activate, like so. Then I'm going to create a transition from the empty state into the elevator state. Then I'm going to select that transition, and the condition for that transition will certainly be when the activate trigger has been set. We'll also turn off has exit time. So what I'll do now is I will press, let me drag out the animator window a minute because I want the animator window on the screen and the elevator on the screen. So I'm going to press play. Okay, at the moment nothing's happening. And imagine now that we activate the keypad. What the keypad's going to do is contact this animator, and it's going to set this trigger to activate it. And this is what will happen. Bump. And look. Our elevator is now moving up towards its target. Just want to check it stops at the end. We don't want it to loop. Although the game will already be over at this point. Okay, so it is looping, so what I need to do in my project view now is drill down into my interactive folder again, select the elevator animation, and you can see that the loop time property is set by default. So we'll untick that. We don't want this animation looping. I'll press play again and just test it. Definitely works. Once again, we activate the keypad. Oh, by the way, just in case you don't know, in the last lesson, we locked the mouse so that you can see at the moment, it looks like I can't select anything. If you just press escape, Unity will give you the mouse back again, and then you can do things like click the activate trigger. Okay, so this time, I'm hoping at least, that our elevator is just going to stop at the top of the shaft and stay there. Perfect stuff. Okay. Cool. Now at the moment, our player FPS controller rig doesn't start off on the elevator, so let's put him on the elevator. This will probably be a little bit bumpy at the moment, okay, because we have to do some additional stuff to make it move up the elevator smoothly, which we'll do in a later lesson. So let's just run that again. click activate. And hey, our player is moving up in the elevator, and you'll notice that that gives a very jerky effect, but don't worry, we're going to fix that. That's because when the elevator is moving up, the physics system is constantly detecting that we're intersecting the elevator floor, and there's a physics reaction happening. So what we need to do is when we activate this elevator, we're going to freeze the FPS controller so that we can no longer move, but we can still look around, and we'll also temporarily, actually not temporarily because it's the end of the game, but in Dead Earth it would be temporary, we're going to parent the FPS controller to the elevator. And if you just want to test that I'm definitely telling the truth, let me just temporarily take my FPS controller, make it a child of the elevator, and then press play, and then activate the animation. And as you can see, that is now as smooth as a very smooth thing. Let me maximize it. Hey, look at that. I don't know why, it's a simple effect, but there's just something really cool about going up in an elevator in a game. Okay, so let me now move the animator window back to where it was before, because that's a ghastly waste of real estate. And what we'll work on now is the actual keypad and its trigger script, which will show us an example of a more complex interactive object using our interactive item framework. Okay, so let's start by creating the graphical representation of our keypad that is going to be mounted on the wall of the elevator. A few lessons ago, we imported a load of assets that were to be used by the Creeper project. The keypad is a texture that we imported. If you select the textures folder, which is a child of the Dead Earth folder, you'll see there is a texture in here called keypad. There's also a duplicate called keypad normal, which we'll use to create the normal map from. So with keypad normal selected, let's change the texture type to normal map, and let's select create from grayscale, and let's move the bumpiness of that thing right down and click apply. That will probably be fine. We also need to create a material for our keypad, so in our materials folder, which once again is the folder that is a direct child of the Dead Earth folder, we will choose to create a new material, and we'll call this keypad. We'll lock the inspector and then select the textures folder again, making sure to drag the keypad texture into the albedo slot of the material and the keypad normal texture into the normal map slot of the material. Let's make this thing look a little bit better by putting the metal slider up quite a long way. We'll leave the smoothness where it is, I think. Yeah, that looks fine to me. Okay, so now we're going to create a cube that we can embed into the wall and map this texture to. So we'll go to the Game Object menu, the 3D Object submenu, and create a cube. Let's just bring it close to us so we can see what it looks like. And then what I'm going to do is take that keypad material we just created and drag and drop it onto our cube, like so. I'm also going to unlock the material inspector so that I can now scale and resize this object to get it the right size. As with the elevator floor, I've made some notes about what the position, scale and rotation of this object should be. So I'm going to pause the video now, type them in, and then I'll zoom in on the transform so that you can pause the video and copy those values over into your own project. So there we have our keypad in its final position. Looks quite small, but that's about the right size, or at least what I thought was the right size. So what I'll do now is I will zoom in on the transform of this object so that you can pause the video, so you can make a note of the position and the scale that I used. I'll also rename this object and call it keypad. Now, of course, this is going to be an interactive object, so we need to assign it to the interactive layer. And we also probably want to be a little bit more generous with the box collider, probably quite a bit more generous. I hate a game where you have to get right on top of something in order to activate it, so we'll make a really baggy collider. So I'll set the X to 1.86, I will set the Y to 2.1, and I'll set the Z to 1.68. It's big enough, but it's still a bit sunk into the wall, so I think I will move this out a little bit. Probably something like 0.6. I think that's better, so when we get around about here, we'll probably be able to activate it, which I think is good, especially if we're being chased by zombies. We haven't got much health left. We don't want the game to cost us a life just because we're being finicky. Our keypad is now complete. What we need to do now is create our new keypad trigger script that is going to do all of the things that we've discussed. It's going to check states with the application database. It's going to contact the animator of the elevator floor and activate that trigger and allow us to end the game. So I'm going to drill down into my scripts folder, into my interactive items folder, and I'm going to create a new interactive item, a C# script, and I'm going to call this interactive keypad. Like so. Then I'm going to select my keypad object and drag my interactive keypad script onto it. Oops, I just noticed that when I renamed this cube to keypad, it didn't take because I forgot to press return. So let me do that now. And then I'm going to open up the interactive keypad script in MonoDevelop. And I'm going to delete the start and update function, and I'm also going to remove MonoBehavior as the base class because this needs to be derived from interactive item, like so. So let's start with the inspector assigned variables. The first thing we're going to need is a reference to the actual elevator object that is going to move. So I declare a transform. It's serialized so we can hook it up in the inspector, and I call this elevator. So next up we need to think about sound. When we activate this elevator, we're going to want the keypad to make a sound, and we're also going to want to hear an elevator moving sound the entire time that we are going up in the elevator. So we will supply this script with an audio collection. Now in this particular case, the audio collection will almost definitely have just one sound in it, or at least in the bank that we're going to use for this task. We don't generally want random keypad and elevator sounds, and in fact you're going to see in a minute we're going to pop back to the editor and we're going to examine the sound that we're going to use, and it's a combined sequence where we have the keypad and that's followed by several seconds of elevator engine sound. So this is a very specific sound, but to keep it consistent with the rest of our system we will ask for that sound to be supplied in an audio collection, because of course audio collections provide other information as well. Even if it has just one sound in it, it's still a useful place to describe what track on the mixer it should play through, what the spatial blend should be, what volume it should be, and also what the priority of that object should be. And whenever we supply an audio collection, we also need to specify the bank. So I declare a protected int, which is once again serialized, called bank. Next up, I declare a protected float called activation delay. I set this to 0 seconds by default, but via the inspector we can specify the time in seconds of the delay that will be used after activating the keypad and before the platform starts moving. Now this is very important in this particular effect because the sound that we're going to use for the keypad and the elevator moving is a combined sound, so we want to wait until the sound of the keypad being used has finished and the engine starts before we activate the sound. So before we go any further, let me save this off. Let's go back to the editor and examine the sound that we're going to be using. We imported it into our project several lessons ago. If we drill down into our sounds folder and into our scene sounds folder, there is a sound in there called elevator activator. As you can see, this is a pretty big sound, so let's press play and see what it sounds like. And as the sound fades out, that's when the screen will be fading to black and it will come up on the screen, level complete. But you'll also notice at the beginning we have a keypad that lasts for about 2 seconds. And you can see, you can actually check, it's really annoying actually that it keeps playing every time I click on there, but about there is where it needs to start. So probably, no, actually a little bit later, about there. Yeah, we'll say 2.2 seconds. Notice the time is along the top of the sound preview window. So we'll set our activation time to about 2.2 seconds. So what happens is when we activate the switch, the platform won't start moving immediately, but we will hear doo 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 on the keypad. And then when the engine kicks in, that's when the platform will start to move. So while we have this elevator activator sound, let's set its import settings. Let's set it to PCM. We don't want compression, and force it to mono and click apply. Also, while I'm here, I'm going to set some of the starting states in our application manager. Like I said, for the elevator to be used, we need to have power, we need to have lockdown turned off, and we need to have the access code. Now in our system, we don't have to put false states into the dictionary, so we could start off with just an empty dictionary, and then when we complete the various tasks, it will set those states in the dictionary. But for testing, it's pretty good to put them in the dictionary in their false states, so that while testing this script out, we can flick the trues to falses and the false to trues. And if that made no sense, you'll see what I mean now. So I'm going to select the application manager, and I'm going to add 3 states to the game state dictionary. The first one I'm going to call power, and I'm going to use all capitals for this, and I'm going to set the value to false. That's because when the game first starts, the level doesn't have power. That's one of the things that we have to turn on. The next state that has to be true is that lockdown has to equal false. When the game starts, we want the lockdown to be true, so that even if we have power, we can't leave the level. So as my second game state, I'm going to set lockdown to true. And finally, even if the power is up and lockdown has been deactivated, we still need to have found the access code. So we're going to have another state called access code, and that will start off as false, but then when we find the access code on one of the dead bodies, this state will be set to true. Okay, so let's continue on with our script now. And first of all, we'll do the getText function. Remember, this is the function that returns the text that is to be displayed on the HUD when the player is hovering the crosshair over the trigger of our keypad. And the first thing we're going to need to do, because we're going to need to check some of the game states, is we need a reference to the application manager in the scene. And I'm going to store this in a local variable called app_database. I call it app_database instead of app_manager because although our application manager will eventually do many more things than just be the game state database, that's all this script is going to use it as. If we were unable to get a reference to the application manager, then we just return an empty string because there's obviously a problem. We haven't configured our scene correctly. However, if we have got a reference to the application manager, we want to use its getGameState function to fetch the states of the power state, the lockdown state, and the access code state. I'll declare a local variable of type string and I'll call it power state, and I will assign to that the returning value from calling the application manager's getGameState function and passing in power as the key that we wish to have the state returned for. You can probably imagine what the next two lines are going to look like. We'll query the status of the lockdown state and store that in a local variable called lockdown state, and we'll query the status of the access code state and store that in a local string variable called access code state. So now we need to check the values of those states and see if they match the criteria that the interactive keypad has for enabling the elevator. We'll check the power state. So what we're basically saying here is if power state equals false, which we know it will at the beginning, or if the string returned is empty. And the reason I put this in there is because, like I said, you don't really need to put false states in the dictionary. We don't have to set power to false to begin with. If it's not there at all, this script will still work because it will return a null or empty string. So we're basically saying if the state hasn't been defined or if it doesn't equal true, then it means we have no power, and the text that we'll return to display on the HUD will simply be keypad, no power. But if we have already restored power and the power state is true, we need to check the next conditional. This time I do the same again, but with the lockdown state. Of course, lockdown is flipped. We actually need it to be false in order for the elevator to work. Then we will return the string keypad under lockdown. So if we get past this test, it means that we've restored power. We're no longer under lockdown. Lockdown has been deactivated, so we need to check if we've got the access code. So once again, we will say if not access code equals true, in other words, if access code equals false, then return keypad access code required. So if we haven't returned from the function in any of these conditionals, it means all of the prerequisite states are set and we can activate the elevator should the user press the use key. So in that case, the text that we will return will simply be keypad. That's how we'll know there's no problem with it and we can use it. Let's now do the activate function. Remember, this needs to be overridden from the base class and takes a single parameter, the character manager. Once again, we will fetch an instance to the application manager as the first half of this function is going to be almost a duplicate of what we've just done above, checking that the states are set so that we can activate the object. If we were unable to fetch a reference to the application manager, then we will simply return. Otherwise, just as in the function above, we will fetch the power state, the lockdown state, and the access code state into local variables. Now we pretty much have to do these conditionals again, only instead of returning a string, we simply return from the function and don't activate the elevator. I'll say if power state doesn't equal true, then return. We can activate the elevator without power. If our lockdown state doesn't equal false, then it means we're in lockdown. Lockdown equals true, so we return. We can't activate the elevator. And if access code doesn't equal true, well then we don't have the access code, so we return. But if all of those states are set to what we need them to be, then it's time to start a coroutine that's going to wait for the activation delay time and then start that animation playing. So we will use Unity's start coroutine function, and the coroutine that we're going to create in just a moment is called do delayed activation. And just like the activate function, we're going to pass in the character manager into this coroutine as well, because it's going to need to talk to the character manager. So let's now work on the do delayed activation function. It's a coroutine, of course, so it needs to return an IEnumerator. The first thing we'll do is check we have a valid reference to the transform of the elevator game object. That's the one that we wish to animate. It's our elevator platform. We need this because the position of the elevator is the position at which we wish to play the sound. And also, we're going to need to fetch its animator component and set the activate trigger in that animator. So first of all, we'll make sure that we have been assigned a valid audio collection reference, and we'll fetch a clip from the audio collection. Actually, that shouldn't be a 0 in there. My original version of this script just hard-coded bank 0, but we've now got a bank property up here. So I should be passing bank in there, but I'm not going to do it for now because I've got the lines in the clipboard and that will really screw up my copy and paste here. But I'll come back at the end and we'll change that to say underscore bank in there, okay? So now that we have the clip, let's check that it isn't null and we did fetch a valid clip from the audio collection. Well, then we wish to play the sound immediately, okay? That's the important point. Although we may have specified a 2-second delay, we wish the sound to play immediately, then the delay to be invoked, and then the animation to play. That's how we get the moving platform to start 2 seconds into the audio clip playing. So we'll check we've got a valid reference to the audio manager, and if we have, we will use its play one-shot sound function, which we're very familiar with at this point. And of course the audio group, the volume, the spatial blend and the priority are all properties directly fetched from the audio collection itself, and as the second parameter we pass in the clip that we've just gotten above, and as the third parameter we pass in the position of the elevator. Now the sound has started playing, it's time to wait for the number of seconds specified in the activation delay variable. So we yield return new wait for seconds, passing in our activation delay value as the number of seconds we would like this function to wait before continuing execution. Next up, let's make sure we have a valid reference to a character manager, because what we want to do is make the transform of our FPS rig a child of the elevator. I will say character manager, and then I will fetch its transform component, and I will set the parent property of the transform component to our elevator. We saw a few moments ago that when we make our FPS rig a child of the elevator, when the elevator moves up, we don't get any bumpy or jerky motion. Next up, we need to fetch a reference to the animator that is on the elevator platform. Remember, when we created an animation for that elevator platform, Unity automatically added an animator component to it. So we're going to fetch that component by saying elevator.getComponent and passing in the animator as the component we wish to fetch from that game object. And assuming we have a valid animator reference, we will call the animator's setTrigger function, passing in the string activate as the name of the parameter that we would like to trigger. Finally, we want to use that freeze movement property that we added to our FPS controller. Now, our character manager doesn't yet have a property that we can use to get its underlying FPS controller, but we'll create that in a minute. So let's just pretend for now that FPS controller is a property of the character manager that returns the FPS controller. And then we will say character manager.fps controller, and we will set its freeze movement property to true. This stops us being able to move left or right or forward and backwards on the platform, but we'll still be able to use the mouse to look around. And that is our keypad trigger script done. So what I'll do is I will just scroll up to the top of the last function and I will fix that error where I was hard coding bank 0 instead of using our bank variable. Okay, so there's no point me going back to the editor yet because we're going to get errors because we haven't yet coded the FPS controller property in our character manager. So let's now call up again the character manager script. I already have this open over here, and I'm going to scroll down to where our properties are defined. There you go, there's our health and stamina properties, and I'm going to create another one under there called FPS controller. So this needs to be a public property that returns an FPS controller, and we'll call it FPS controller with a little FPS. Let's tidy this up a little bit. Only needs a getter, and it will simply return the underlying FPS controller member of our character manager, like so. So let me save that off now and go back to the editor and see if we have any errors. And no, we haven't. So what we need to do now is we need to create an audio collection that we can put our elevator activator sound in. So I'm going to select my audio collections folder, which I'm trying to remember where that is. Oh, it's in my sounds folder and in my audio collections folder. And with that folder selected, we'll go to the assets menu, the create submenu, and we'll choose to create a new audio collection, and I will call this elevator, like so. We need to assign this to the scene audio group. I have no idea what the volume should be, so let's just put it down to about 0.3. Spatial blend needs to be 0. It needs to have one bank in it and one sound in that bank. We'll leave priority at 128, and I'll lock the inspector, call up our scene sounds folder, and drag my elevator activator sound into that. So next I'm going to unlock the inspector, and I need to select our keypad game object in the hierarchy, and we need to hook up and configure the script variables. So for the elevator property, we need to drag over the transform of the actual elevator platform so our keypad script has access to it. And for the audio collection, of course, we can probably just use the picker for this. We need to use our elevator audio collection. We can leave bank at 0, and I think we decided that the activation delay was going to be around 2.2 seconds, right? Okay, so let's now press play. Actually, I've just realized something massive, and that is that when I created my collider on the keypad, this is supposed to be a trigger. That's really important, or otherwise it'll be a solid object that we can't pass through. And I'm just thinking whether I left all of those colliders that we put on our ammo boxes and our barrels as colliders as well, and didn't set their is trigger booleans to true. So let me make this a trigger first of all, and then I'm going to open up my ammo boxes list here. Yeah, look at that. I left them all as solid objects. So I'm going to select all my ammo boxes, configure them to be triggers. I'm going to select my battle bus because my battle bus has an info object on it as well. I'm going to select all of the canisters, make those triggers. All of the jerry cans, and make those triggers. And I also put info objects on these piles of tyres as well, didn't I? Yeah. So I want to select all of the tyres and make those triggers as well. God, I'm glad I spotted that, because that could have had me scratching my head a little bit. Okay, so let's press play and see what happens. Now, we're not going to be able to use the keypad right away, obviously. Because, look, we have no power. Okay, what's happening there? Okay, I probably need to move that trigger in a little bit more. You need to be careful when you set triggers that if the ray actually starts off inside the trigger, then it won't actually register as a raycast hit, apparently. So let's just move that back a little bit by adjusting not the object but the box collider. So what is that on the Z? No, not the Z. I need to move it back that. No, not that. Okay, so I need to move the X back a little bit, like so. Let's try that. Okay, that's better. As you can see, at the moment, it's telling me that it's a keypad, but it's got no power. And when I try to use it, nothing happens. Okay, so this is where we can start to test our scripts. Let's select our application database. And this time, let's change the power state so that it starts off as true. In which case, our script will think that power has been restored. So... and you can see it's given us a different message now. Instead of saying no power, because the power as far as our script's concerned is now activated, it says under lockdown instead. So you can probably imagine if we then set lockdown to false, it will tell us that we haven't got the access code. So let me put this from free aspect into 16.9. And there you go. And now it's telling me that the access code is required and we still can't use it. But what I'm going to do now is I'm going to set access code to true, and we should now be able to use the elevator. Fingers crossed, folks. And I'm stuck in place, and as you can see, the elevator started to move as the lift went up. Isn't that awesome? Should we try that again? Because it's just too good not to do twice, right? Okay. So imagine we're being chased by zombies. Leave me alone. Come here, whack that thing, get ready, and notice that as soon as it starts moving, the elevator, the FPS controller is stuck in place, but I can still look around and look down at the zombies that were trying to kill me. So there you go, there's our interactive keypad and our entire elevator and endgame sequence complete. So I'm going to leave the starting states like this for now, because next up we're going to put a trigger at the top of the elevator shaft that's going to detect when we enter it and detect that basically we've completed the level and that's the end of the game. Actually, I have just had a thought. I'm going to open back up my interactive keypad script and I'm going to put a Boolean private variable in it. The reason I'm doing this is because it just occurred to me that if we were to go up to the keypad and double tap the use key very quickly, we could try to activate it twice. That wouldn't be the end of the world, but it might cause 2 one-shot sounds to be spawned, and that would sound kind of weird. So I think what I'll do is I'll create a private boolean called isActivated, and we'll set it to false by default, and then in our activate function we'll return immediately if we're already activated. So we'll say if isActivated return, and then after where we start the coroutine we'll say isActivated equals true. So this function should never get a chance to call the coroutine again. I should probably just make sure that that definitely works. That's cool, so it works. Now what I'm going to do is try and do a double tap and see if I can get it to double play a sound. Yeah, no. Work like a charm. Okay, that's cool. Okay, so let's now do the mission objective. This is going to be a trigger not that far up the elevator shaft, because our elevator engine sound doesn't actually go on that long, so probably around here somewhere. And when the player passes through that trigger, that's going to eventually kind of cause a scene fade out, come up mission success on the screen, and then ultimately load in the title screen or the closing credits scene, or whatever we want to do after the game has been complete. So firstly, let's now unparent our FPS controller rig from the elevator, and then I'm going to duplicate the elevator because it's already roughly in the right place, almost the right size. So I duplicate the elevator by clicking duplicate, and I'll rename the duplicated elevator mission objective, like so, and then I will move that up to about here, probably still too high actually, probably something like that. We'll move up for a few seconds, and when our collider passes through this trigger, that's when we'll start our 2 or 3 second fade out. So we don't need a mesh renderer there, I'm just leaving it on there for the moment so we can see what it looks like. And let's be a little bit safe, let's just drag it out so there's no way that we can actually miss it, something like that. And then we'll turn off the mesh renderer. We'll make sure that the box collider is set as a trigger. We can leave it on the default layer. Actually, I've made that a bit too big now, it looks kind of really ugly, doesn't it? And I'll bring it a little bit in on the Z as well. What does that look like from the top? Yep, looks good to me. And then what we can do is put a script on this that detects when the character manager has entered it, and then we'll say to the character manager, hey, you've completed the game, buddy. So let's create a mission objective script. Oh, before I do that though, let me remove the animator component from our mission objective object. Remember, we duplicated this from the elevator, and the elevator has an animator on it. So let's remove the animator component from that duplicate we made. Okay, everything is how it should be. So now I'm going to drill down into the scripts folder, and I'm going to create a new C# script in there, and I'm going to call this mission objective. Like so. Then I'm going to select my mission objective game object and drag and drop our mission objective script onto it, and then load the mission objective script into MonoDevelop. We'll delete the start and update function, we won't need them at all, this just needs the onTriggerEnter function. So remember, the onTriggerEnter function is one of Unity's magic functions, which will be called automatically by Unity when a collider enters the trigger that this script is on. And we are past the collider. Of course, we don't want the collider, we want to know if the game object of the collider has a character manager script on it, and if it has, then we'll contact the character manager script and we'll tell it that it's the end of the game. We will first check we've got a valid game scene manager, and then we'll use the game scene manager's get player info function. Remember, just like our AI state machines and our interactive items, the game scene manager maintains a dictionary of player info objects that are stored by Collider ID, and the player info object contains lots of useful information about the FPS rig, and more importantly in this particular script we can get access to the character manager from it. So the collider that we've been passed, we can get its ID and we can see if it's actually the player, and if it is, we'll get returned back a valid player info object. So assuming we have got back a valid reference to a player info object, we will access its character manager property, and we will call a function of the character manager that we haven't implemented yet called doLevelComplete. And let's save that off now and go back to the character manager and implement this little function that's going to essentially end the game. Now we can't end the game properly at the moment because in the real game what's going to happen is it's going to go back to the main menu screen, but we haven't got a main menu screen yet. But we can at least display some text on the HUD and fade the scene out. So let's scroll down to the bottom of the character manager class and add the function there. So it's a public function called doLevelComplete. has a void return type, and the first thing we'll do, even though it's not technically necessary in Creeper, is we'll just make sure that the movement of the FPS controller has been frozen. Now we know that in Creeper we're already on the elevator and the keypad trigger will have already frozen our movement, but of course we might be using this script in some other scenario where the movement wasn't frozen when the character reached its end of level goal. So we're just going to make sure at this point we're going to freeze the movement definitely if it wasn't frozen before. Then we want to output some text to our HUD, so we'll check we've got a reference to the player HUD, and we'll start the HUD fading out by using the player HUD's fade function. We're going to do a very slow fade here, a 4-second fade, and of course as the second parameter we pass in the screen fade type, and this time we want to fade out, whereas at the beginning of the level we fade in. And the text that we want to display is mission completed, and we use the show mission text function, which we know will assign it to the mission text UI on the HUD, and that's the big bold text across the center of the screen. And what the hell, we'll also invalidate the HUD. I mean, not really necessary, but let's just make sure that if any health is changed or stamina is changed, that we reflect that immediately when we do this. And next we want to invoke the game over function. We'll write the game over function now. That's the function that actually will return us back to the main menu. Of course, we don't have any functionality yet to return us to a main menu. We don't even have a main menu scene. So for now, we'll just make sure that we re-enable the mouse and unlock the mouse cursor. And I'm going to use the invoke function for this and call the game over function after 3 seconds. And the game over function itself at the moment will simply set the cursor to visible and set the lock state to none so that our mouse comes back. And that's what will need to happen when we go back to a main menu screen, because the main menu screen will have some options that we can choose from, and we're going to need to be able to select them from the mouse. So it's very important that when this level is complete, we get to show the mouse cursor again. And I'm going to put this in commented for now because we haven't yet implemented the function. But what this function will ultimately do is call the application manager's load main menu function. But we don't have a main menu and we don't have this function yet. So I'll just comment this out for now. But you can see roughly how this is going to work. Actually, it makes no sense. Why am I invoking this function after 3 seconds? It should be after 4 seconds, shouldn't it? So it matches the screen fade. Okay, so let me save that off. Go back to the editor and see if we've got any errors, which we probably have. And no, we haven't. So let's press play now and let's see if any of this happens. Okay, let me maximize the window. Okay, so one thing that I just noticed, and let me try it again. I'm going to call up the game window and I'm going to go into free aspect and I'm going to make the screen really wide, okay, like ridiculously wide. Then I'm going to run the game again. And you'll notice that that big black UI element that does our screen fade is not actually big enough when we do silly things with the screen. You can see the black square, see? And you'll probably see it again when I activate the elevator and the scene fades out. Yeah, see? So we need to really make that thing a heck of a lot bigger. So I'm going to select our player HUD, put the scene view into 2D mode, and zoom right out so I can see what's going on. And then I think I'm going to put the mode back into 16:9, and I'm going to open up and select the fade object. And we need to make this like massive, don't we? Like stupidly big, so it can never ever not be big enough to cover the whole screen. Okay, so let's open it up really big like that. Make sure that the game mode is in free aspect again, press play. Yeah, we can't see any edges there now, can we? And we'll just check it on the fade out. Okay, that's cool. Well, I'm going to leave it there for this lesson, guys. And in the next lesson, we're going to create a very important script. It's going to be an interactive item, but it's going to be what I call my generic trigger script, which can do all sorts of crazy things and be used in lots of different places throughout our game. It's going to be a trigger that can listen to any number of states, can set any number of states, can swap materials, can send parameters into any number of animators, can enable and disable game objects, particle systems, whatever. So this is a really funky script that can do a lot of stuff. I look forward to it. I'll see you next time, guys. Bye bye now.